measurement of three-phase power using two wattmeter method. The aim of this experiment is to determine three-phase power by using two wattmeter method. So the theory behind this experiment is there is a wattmeter is the instrument which is used to measure the power in an electrical circuit. It consists of a current coil which is connected in series with the circuit through which the line current flows through a potential coil, that is CV, and M and L, it is a current coil, C and V, it is a potential coil, which is connected across circuit. The way in which wattmeter connected to the measure the power in single phase circuit is as shown in figure 5.1. So the figure it can show here the supply, it is connected to M and L. The load will be connected. M and C has to be shorted. V is directly connected to the supply side. So this is the figure of the circuit. In this, we can measure the power by using two wattmeter method. Here to measure the three-phase power, three single phase wattmeters may be connected in each phase, but the algebraic sum of their readings gives the total power consumed by three-phase circuit. But here we can use the two wattmeter method, can employ to measure the power in a three-phase in three wires star or delta connected, the balance unbalanced load. So in the two wattmeter method, the current coils of the wattmeters are connected with any two lines, say R and Y, and the potential coil of each wattmeter is joined on the same line. The third line is B as shown in figure. You can see here the R is connected to the one wattmeter, B is connected to the another Y is connected to the W2, and remaining the resistance it has to connect it in the series. Either it will be in the star, either in the form of delta. But here the two wattmeters connected to measure the three-phase power. Here, the total instantaneous power absorbed by three loads Z1, Z2, Z3 are equal to the sum of the powers measured by the two wattmeters W1 and W2. So this is the circuit diagram as we can see here. Circuit diagram. Here there is a three-phase supply. It is connected to the TPST switch, fuse, and there is a three-phase auto transformer. There is ammeter is connected to the one wattmeter, and voltmeter is connected across the load. Okay, and there is a two wattmeter W1 and W2. It is directly connected to the R1 and R1 resistance and R2 resistance. The middle wire it is directly connected to the R3. Okay, and here the rating of wattmeter is 600 volts, 10 amps. There is unity power factor wattmeter. In this, you can see the connection here. The one end of the ammeter is connected to the M and C should be shorted. L is connected to the load. V and first wattmeter V and second wattmeter V, it is connected directly to the middle wire, and also it is shorted to the load side. And this is the circuit diagram for this experiment. Here, some of the precautions you need to follow while doing this experiment. The TPST switch should be in off position. Three-phase auto transformer must be in 0 position. Lamp load should be in off position. And the procedures, you can see here, the connections are made as per the circuit diagram. Close the TPST switch and set the supply voltage to 400 volts using three-phase auto transformer. Increase the load in steps. Note down the readings of ammeter, voltmeter, and wattmeter. Repeat the steps for different loads. Switch off the lamp load. Bring back the auto transformer to 0. Switch off the mains. So these are all the procedures we can go through here. Tabular column you can see here. In this tabular column, you need to note down the voltage, line current, and also you need to note down the W1 and W2, and also you need to note down the total power. You need to calculate the total power W1 plus W2, and also you need to calculate the power factor, that is cos phi. Here the calculations, the total power P is equal to W1 plus W2 in watts. We find the power factor cos phi is equal to uh, cos phi is equal to cos tan inverse of root 3 W1 minus W2 divided by W1 plus W2. So this is the power factor formula. So these are the some of the Viva questions we need to focus here. So in this experiment, the objective of this experiment is to measure the power, three-phase power, and also you need to calculate the power factor by using two wattmeter method. Now we can go for a demonstration and demonstration of this experiment. And before the demonstration, we need to do some connections. We need to connect the equipments. We need to see the equipments. So this it will be some theory explanations. Whatever we did it.
We'll see the connections of two wattmeters for a three-phase load. So we can observe here the three-phase loads with R, Y, B phases connected with the help of two wattmeters. Two wattmeters are having the terminals M and C and L and B. So here we can see that ammeter connected in this R phase. So this will be the input terminals of auto transformer R, Y, B, and output terminals of auto transformer is again R, Y, and B. So output of auto transformer R line is connected with an ammeter to the wattmeter, and through the wattmeter we are connecting it to the R phase load, and from the Y line we are connecting it to the load, and from the B line also through the second wattmeter we are connecting it to the load. So between R and Y phases we are connecting a voltmeter. This voltmeter is called as line to line voltage measuring voltmeter, which will measure the voltage of input voltage of 440 volts. So between any two lines we are connecting the voltmeter. You can connect this voltmeter here also. So but we have connected between R and Y phase to measure the line voltage VL. So this will measure the line current IL, VL, IL, and through the watt. So now let us understand the connections according to this circuit diagram. So here we have three-phase auto transformer. For the three-phase auto transformer, input should be given from the 440 volts supply. So that we can observe here from the switchboard, you have the cable connection. So that is given as input to the three-phase auto transformer. Three-phase auto transformer. Okay, so the input cable, so these are the upper terminals are input terminals to the auto transformer, and lower terminals are the output terminals of the auto transformer. So from the output terminals, so that is from the lower R, Y, B terminals, so we are giving it, we are taking this as output terminals and we are giving it to the wattmeter. So now let us see this from R phase. Okay, we have taken two wires. So these two wires are given from these two wires we are giving connection to, okay, so one to the voltmeter, okay, voltmeter first end, and other to the ammeter. So that we can observe here in the circuit. So from the R phase, okay, so from the R phase, so we are giving to voltmeter and also to the ammeter. So from the R phase of the auto transformer, one end is given to the ammeter and other end is given to the voltmeter. Again from the ammeter other end, here we can observe it is given to M of wattmeter, and M and C of wattmeter should be shorted. So from the ammeter other end, okay, from the ammeter other end we can observe here it is given to the M terminal of the wattmeter. Again from M and C terminals must be shorted. So for that shorting, here we are using this blue wire to short from M to C. Again if we come to the circuit here, from the L terminal of the first wattmeter, it is given to R phase of the lamp load. So that also you can observe here from the L terminal of the wattmeter, okay, from the L terminal. So we are taking a wire, so that is given to, okay, R phase of the lamp load. So which is given to R phase of the lamp load. Okay. Again in the circuit you can observe here, okay, from the Y phase of the auto transformer is given to Y phase of the lamp load. So from the Y phase, the output of the auto transformer is given to Y phase of the lamp load. So that also we can observe here from the Y phase of the auto transformer, okay, is given to, okay, so this wire you are connecting it to Y phase of the lamp load, okay, Y phase of the lamp load. Again from the Y phase, okay, from the Y phase, okay, one more wire is taken. So again this one more wire here, that we are connecting it to, okay, other terminal of the voltmeter. So this other terminal of the voltmeter, here we can observe that it is obviously 600 volts. So why we are taking 600 volts? Here you have two ranges, 300 volts and 600 volts, but we are selecting 600 volts because input voltage whatever we are measuring is 440 volts. So obviously we have to select a range in the voltmeter so that one common terminal is COM, that is 0 volts terminal is common. But when we are connecting to the other terminal, we have to look into the input voltage. So we are giving 440 volts, so 600 volts would be the higher range when we are giving 440 volts as input. So we are connecting to 600 volt terminal. So the voltmeter, COM and the 600 volt terminals is connected to, okay, R and Y phases of the auto transformer output. It is given to R phase as well as Y phase. So here we understood so that voltmeter is connected between R and Y phase, and also through this R line we are giving to ammeter, again to the wattmeter, again from the wattmeter we are connecting to the lamp load. So if you come to the B phase of the wattmeter or auto transformer, so here you can observe that from the B phase of the auto transformer output. So from the B phase, okay, we have to give it as to the M terminal of other wattmeter. So from the B phase, we are connecting it to, we are connecting this to the M terminal of other wattmeter. Again M and C of the second wattmeter is also shorted by using a green wire here. So we can observe that MC is shorted, and that we are observing here, okay. In the circuit also, again from B phase it is connected to M. M and C should be shorted, so that we are seeing here from B phase the blue wire is connected to M, and M and C are shorted by using this green wire. So if you observe next connection, we have from V phase of the second wattmeter is connected to V phase of first wattmeter. So sorry, it is not V phase, so we can take it as V terminal. So how to select V terminal in the wattmeter? So here the range of wattmeter is given 600 volt, 10 amps, UPF. So we have to select 600 volt terminal in the wattmeter as V terminal. So that we can observe here in the wattmeter. Okay. Here also for the wattmeter they have given two ranges, 300 volts and 600 volts. But input voltage, since we are giving 440 volts as the supply voltage, so I am selecting 600 volt terminal as a V terminal of the wattmeter. So from the wattmeter V terminal, okay, so V terminal of this wattmeter is connected to V terminal of other wattmeter. Okay, so V terminal of the second wattmeter is connected to V terminal of the first wattmeter, and from the V terminal of the second wattmeter, okay, here we can observe it should be connected to Y phase of lamp load, or it should be connected to Y phase of auto transformer. So we know that we have shorted from Y phase of auto transformer to the Y phase of the lamp load, okay, but V and V terminals also we have shorted, but we can see a continuous connection here. So V and V are shorted, and also this Y is connected. So any one V terminal of either this wattmeter or of this wattmeter, so any one V here we are connecting to this line. Okay, so this Y line. So that means you can connect from this V to Y phase of auto transformer, or you can connect from V to Y phase of the lamp load. So that also we can observe here. Okay, so from the V terminal of the second wattmeter, I am connecting it to Y phase of the lamp load. Okay, so for the Y phase of the lamp load here, I am connecting from the V terminal of the second wattmeter. V terminal of the second wattmeter. Again, L terminal. So again we see here some the circuit from L terminal of second wattmeter is connected to B phase. So L terminal of the second wattmeter, from here we are reconnecting it into B phase. So from the L terminal of second wattmeter we are connecting it to B phase. So this is what is about the connections for 2 wattmeter method.
Neutral.
So one more connection we have, it is an additional connection. Here we can observe in the circuit output of auto transformer is only R, Y, B terminals. But there will be a common terminal called neutral which is not shown in the circuit. But if you see the auto transformer, you have one more terminal that is a black terminal. Okay, on the input side also you have this neutral, on the output side also you have this black terminal that is neutral. So from this neutral terminal of the auto transformer, okay, so it will be connected to neutral of the lamp load. Okay, so in order to continue the loop, okay, so there should be a return path for the current, so we have to short neutral to neutral. Neutral of lamp load should be connected to neutral of the auto transformer, neutral of the auto transformer. So you can see the connection like this. Okay. So now let us go into the procedure. So before that, let us see the precautions. So the TPST switch should be in off position, or three-phase auto transformer must be in zero position. Lamp loads should be in off position. So that we can observe here. TPST switch is in off position. Okay. So auto transformer should be in minimum position. This is one of the major precaution. See, always you observe this auto transformer. Okay, this variac should be in zero position, because if you without checking this, maybe it will be in the maximum position like this, okay, at 400 volt points, and if you immediately switch on, if there is any wrong connection, we are getting directly 400 volt supply from the auto transformer. So never do that. Always don't forget to check that auto transformer should be in the minimum position like this. Okay, and all the lamp loads are in off position, so that is all the switches should be off, so that all the lamps are in off condition only. So that we have to ensure. Now let us go to the procedure. So connections are made as per the circuit diagram. Okay, so close the TPST switch and set the supply voltage to 400 volts using three-phase auto transformer. So let us close the TPST switch. Okay, so let us close the TPST switch here. Okay, so you are getting the supply voltage, so the lamp indication. So now you have to increase gradually by using the three-phase auto transformer. So by increasing this auto transformer, you have to increase very slowly, so that we can observe the voltmeter reading here. So we also know that the voltmeter is connected to 600 volt terminal. So you can observe in the voltmeter here, they have given two ranges, the lower range and the upper scale. So let us take the readings in the upper scale, because we have connected it to 600 volt terminal. So upper scale is 0 to 600 volts. So when you are increasing the auto transformer output here, okay. So here we can observe that, okay, so gradually increase that. So because there should not be any, if there is any wrong connection, immediately you will observe a sound or a noise from the auto transformer. So you have to gradually give the input voltage to the auto transformer. Okay. So now we can observe that by increasing the three-phase auto transformer, I have set it into the maximum position like this. By setting it to maximum position, we can observe in the voltmeter, we are getting 400 volts as a maximum voltage. Maybe we have to get 440 volts, but for setting maximum position in the auto transformer, we can get only up to 400 volts. So no problem. 400 volts is also a three-phase voltage. So plus or minus 20 volts tolerance will be there. Now after setting the voltmeter to 400, we can observe this ammeter is showing zero reading. So there is no current which is flowing in the output part of the circuit. So here we can observe that the ammeter reading is zero. Why the ammeter is showing reading zero? So there is no current flowing in the R phase, Y phase or B phases. So in order to that current should flow in the output phases or in the lines, what we have to do is you have to switch on the lamp load. When you switch on the lamp load, immediately all the three phases will carry the current and wattmeter will give you the reading. So input voltage we have given it as 400 volts, and also the wattmeters 1 and 2 are showing zero reading because the lamp loads are not switched on and there is no power drawn by the lamps. So now we have three phases in the lamp load. So for our purpose, since you have the three phases in the lamp load, let us do the connection, or let us switch on the bulbs, okay, in a balanced way. So let us do it for a balanced load. So what do we understand from balanced load? In all the three phases we will switch on the equal number of switches. In our phase also, let us switch on the equal number of switches. So for taking the readings, let us switch on three switches each in all the three phases, that is in R, Y, B. So the bulbs are on, we can see in the lamp load, okay, it is glowing. So since the bulbs are on, now the power lamp load is drawing the power. Now we can observe the ammeter reading. So here you can observe that ammeter reading, okay. If you closely observe that, it will be after 2 amps and between 3 amps, between 2 and 3 we have 10 divisions. So and each division may be 0.1 ampere, so it is around 2.3 amps. So 2.3 amps is the current. So here we can note down that. So supply voltage is common, 400 volts, and 2.3 amps is the current. And observing wattmeter readings, okay. So W1 wattmeter reading is, so it is 0 to 300. Between 0 to 300 you have the long line. So this will be 100 volts, sorry, 100 watt, 200 watt and 300 watt, and all the short lines we can take it as 10 watts. So this way can take it as 100 watt to 200 watts. So W1 is again, okay, 200 watts. And if you observe W2 is also again between 0 to 300 we have a long line, and middle lines are short line. So this will be 100. Between 100 and 200 you have 120, 140, 160, like that, 120, 140, okay. So we can write W2 reading also has 140, okay. Now let us do it for the next phases. So by switching next three switches each in the lamp load, okay, again you can observe the voltmeter reading, okay, it remains the same as 400 volts. So let us record 400. Ammeter reading, it is showing it as approximately 3.7 ampere, okay. And if you observe wattmeter reading, so wattmeter is showing after 300 again each small line, okay, with 300 this will be 400, and this will be 500, and this will be 600. So between 300 and 400 you have only 5 lines. So each small line we are taking it as 20 watts, so 320, okay. So W1 is 320, and similarly W2 also, if you observe, again it is the same way, 320, 340, 360. So here we can record that as 340. So 340. Next, let us switch on the equal number of switches. So if you observe the third phase, okay, so that is we have switched on all the phases or all the switches in the lamp load. Again let us take the reading, okay. So the input voltage is same as 400 volts only. The current is around 5.9 amps. So current is around 5.9 we can observe here. And W1 reading, okay, so wattmeter W1 reading is again 300, 400, 500. After 500 you have 20, each small line is 20 watt, 520. So W1 is 520. And if you come to W2 is again 300, this is 400, and this is 500, it will be 520, okay, 540, 560, 580, 600. So this we can take it as 540 watts. So W2 is also again 540 watts. So this is what is about recording the readings. So now let us switch off the lamp load, okay. In the let us switch off all the switches. So the load gets heated very fast, and we have to reduce the input voltage in the auto transformer immediately to 0 volts, okay, and switch off the mains. So after switching off the mains, now let us go for doing the calculations and further. So here there is no need to calculate the power factor, okay. So for three-phase circuit, if you calculate the total power consumed by the three-phase load is enough. So total power will be summation of the two wattmeter readings W1 and W2. So if you observe W1 and W2, so after taking the readings, here we have to take one more factor called as multiplying factor. So here we can observe in the wattmeter, okay, we have taken 600 volts range, so 600 volts, okay, and 10 amperes. So for 600 volts and 10 ampere, corresponding value is 4. So multiplying factor is 4. If you had taken 300 volt 10 amps, it will be 2. But we have taken 600 volt 10 amps, multiplying factor is 4. And similarly, in the other wattmeter also you can observe here, the other wattmeter is also having 600 volts only and 10 amps only. The multiplying factor is 4. So let us multiply, okay, W1 reading into 4 and W2 also into 4. So for calculating the total power, you have to multiply all the readings by the multiplying factor. So 200 into 4 will be equal to 800. Again 140 into 4, again it will be so please multiply the multiplying factor and then we have to calculate the total power. So here for first reading, if I get, so 800 plus this will be 360. So 800 plus 360 will be, so in the similar way calculate the total power for the other two readings also. So the calculated power is not there, so total power is enough. So these two columns you can eliminate and consider only the total power. So what we understood from this experiment is, for a three-phase load with a three lines, we can measure the total power by using the two wattmeters. So W1 and W2, if you add the two readings, you will get the total power consumed.